Hello everyone, welcome to another day of Advent of Code. This day we will be solving day 14, which I've left unsolved so far because I thought it would take a longer time to implement and I didn't have that much time. So today I'm going back to that day and we'll see if it's going to be as time consuming or not. So the basic description of this problem is that we have a map where we have some stones, or rocks that kind of float up from their original position. So when you tilt a lever, the rocks will slide up as far as they can go, and there are these hash characters which are kind of blockers that block the stone from going further than that. So when it hits this hash, it no longer moves further. So that's about it. Our goal is to kind of float those stones up and then calculate a value from that. So we notice that the support beams along the north side of the platform are damaged. And to ensure it doesn't collapse, we need to calculate the total load on the north support beams. So the amount of load is equal to the number of rows from the rock to the south edge of the platform, including the row on the rock is on. So we calculate basically 10 for this one, 9 for this one, and so on. And the total load in this example is then 136. So let's try to implement this. I'll take the sample input, and what I will do is, of course, as usual, read all lines to read all the input, and then I will build up a map, and that map will be array of, maybe I will do width, which will be input 0 length, and height, which will be input length. And I will do then width, height, so XY. And now I will turn that input into that map. So that's exactly what Copilot is suggesting here. So now that we have everything there, we will do the tilting. So I will do a method that will do the tilt. So tilt. As an input, I will take the map. And now, tilt up. Yeah. So our goal is now to find all the stones and to move them upwards as far as possible. And I'll also have a method that will calculate load. So that will calculate the total load. So for the tilting, I think for a most efficient solution, I should go essentially upward from the bottom, and when I encounter a hash, I do nothing. When I encounter a dot, I do nothing. When I encounter a stone, I count the stones, and I count them until I reach either the top or I reach a hash. And at that moment, I kind of when I'm encountering the stones, I replace them with a dot. So I kind of clean up that column, and when I reach a blocker, which is the top or the hash, I then output all the counted stones one after another there. So that will mean that I will have all the stones. I will output all the stones at once, and I will make this way more efficient. That I will not have to go through the map multiple times unnecessarily. So I will start at the bottom. So for x left and width, so maybe I will do and height, width and height. So I will start from the width, and I will go like this. I make it static so it's clean and separated. So this will have an input of map and int width, int height. I could use get length, but this is more clear. So now what I will do, I will go through the columns, start at the bottom of the column, go up and count stones and replace with empty. When a wall is hit or when at top, output the stones, the counted number of stones. So this is kind of the pseudocode of what we are going to do. So position will be y will be height -1, and I will go up. So while y greater than equal or greater than 0, I will. So if map x y equals and O, is this the small lowercase, is uppercase, or is it the 0? Oh, just copy it just to make sure. So it's O. So when we stones, so we add up a stone and replace that point with oh, actually this belongs here. So we count the stones and replace with empty. If we hit a wall, if map x equal to a wall, then we output the counted number of stones. But we also need to do it when we reach the end. So I would maybe do something like output stones, which will take in a number of stones plus the int y, which will output the stones from that position downwards. So for I less than stones, I will do +1 plus I and output the stones. So this will output the stones from that position, and then I will do output stones. Just a moment, I need to pause the recording. Just a moment. All right, I'm back. Sorry about that. I had to take care of a call. So now we are outputting the stones. So what we want to do is when we hit the wall, we output the stones from that position upwards. So the number of stones and our current position. And we then clean up the number of stones, setting it to 0. And then we continue to the next position. And at the end of the whole thing, we also output the remaining stones that we might have encountered so far. So we should be at this point or greater than or equals to 0. We should have output everything. So basically that's that. And then yeah, so that's basically what we wanted. It's like if this number of stones is 0, then this will not output anything, so that's fine. So this should be the tilting operation, and we can maybe test it out by doing this this exactly, and then doing exactly output the map. So let's do it just to see if we didn't miss something important here. So I will run this and we might see how the map looks after the operation. So let's compare this to this one. So it seems that it could be okay, I guess. Yes. So now let's calculate the load, and the load would be now the number of, so for y equals, so we go through the height to x, and then we calculate the load, the total load. So if we encounter a stone, then we calculate its the load of that stone will be the y coordinate, which is height minus y. So that should be its. So if we have it's from 1, so the height is 10 minus 0. So yeah, that should be it. So the total load would be this, and then we return the load. And hopefully, if I didn't miss something important, we should be able to get the right output. So calculate load, run it. 136, that's correct. So now let's comment out this for now, and then let's take the full input and let's hope it works. So it's 113,000 something. So let's see. And that is correct. So that's the first part of the problem finished. And now let's continue to part 2. So now we're doing a spin cycle, which tilts the platform 4 times so that the rocks roll north, west, south, and then east. So we essentially first move them up, then west, south, east, and so on. So it's a kind of 4 directions of the same thing, and we need to do this a lot of times. So that's a lot of cycles. So what we can try to do is to see if it will be efficient enough to handle this, handle the full simulation, or we will need to optimize things. So I will do this first. What I would like to do is to have some kind of rotate counterclockwise, and that would rotate the map and out like rotated map. So essentially I would have 2 maps. One would be rotated map, or with height width, because like the rotated one needs to have a swept axis. So this method would rotate the map. So static void rotate counterclockwise would take a map. Source, target, and source width, source height. So what we'll do is that so target width, height is source width, so swapped coordinates, and now to rotate left, it means that this then, so we rotate, so by rotating, well, let's think about this. So to the north, then to the west. So it means the top is now this side. So we need to rotate clockwise instead. I was wrong there. So clockwise, and we will essentially rotate it clockwise. So the item that's here should be in the bottom right of the new version. So essentially we move this one to the end and so on. So So it should be, so a given x becomes new y. So from source x, y becomes, x becomes new y. So this is going to be x. And now y of the item becomes its, wait, yeah, so it becomes so the y becomes width minus, target width minus the y coordinate, target width minus y coordinate, if I'm not mistaken. So this should give us the right calculation, -1, of course, -1. So just to verify, if we're here, 0, 0 should become target width -1 and 0 on y coordinate. So this should be okay, if I'm not mistaken. So technically this should rotate the source array to the given target array, and that's it. So what we will need to do for a number of cycles, for cycle it's gonna be a lot of them, so cycle plus this number. So let's do it as a long, just in case. Cycle plus plus, and then we for I will tilt up and then rotate clockwise, where so current width will be width, current height will be height. So current width will be the source width, current height will be source height, and then I need to swap them, and we need to swap them, swap also axis. So this way we should be able to rotate it the requested amount of times and then calculate the load. We'll see how fast it goes. It's gonna be probably slow, I guess. Yeah, it's not too fast, I see. So we'll see how far we are now. So it's yeah, like that's so this is how many? So 3 is for 1 billion, and this is 2 million. So it's gonna be very slow. So what we could do is to somehow skip like what I expect can happen. Actually, what I can do is let this run in the code, like while we're coding, and I need to move this here, of course. So let's see, put this here. Let this run. So what I can do to make this more efficient, and I will need to undo my changes here because I broken the original solution. Let's see if it can undo everything. Yes, it can do. So yeah, what I would like to do is to find a way to skip some cycles when I already know that I encountered them. So what I mean is that when I start this cycle, I can calculate some kind of hash of the current state. And if I already seen it, I can jump forward a number of times so that I can skip everything I've already seen and just calculate the requested change that is needed. So I will do something like long. Let's do it like this. Long visited. No, maybe like this. Hash set of long. Right, dictionary is fine. So dictionary of int long visited, and this dictionary will contain as a key the hash of the current map state, and as a long the number of steps we took to reach that point. So now what I can do is create a method called hash map, which will take a map and width and height, and I will calculate a hash for that. So come on. So yeah, so this is some kind of hash here. I'm not sure if that's enough, but we can try this. And this hash number will give us a unique key that we can check to if we already seen this point, like this configuration before. So hash, I will take the map, and then I will, if it already contains the visited key, I will take my current cycle, and yeah, so exactly, it already predicted what I want basically. So it gives us the cycle length, the length of the distance from that point in time where we already seen this configuration. Now we take the remaining cycles and calculate how many. This is odd. I'm not sure if this is what I want. Rather, I think this is what I want. So remaining cycles, the number of remaining cycles, I divide it by, all right, modulo. So so we add it. So essentially, when the remaining number of cycles, we can increase our current cycle ID by the given number of cycles times cycle length. So this will skip. So this will fast forward us into a point of time where we have exactly this same configuration, but at a different point in time. So now we will be, instead of processing cycle I, we will be processing cycle J, which is equivalent, but more in the future with the same configuration. So this should be fine, I think, if I'm not mistaken. So with the remaining cycles divided by cycle length. Yes, if I didn't miss something, it could be it. So this will fast forward us, and that would make it much easier to calculate the solution. Yeah, we can clear it at the end so that we don't do it. We don't try to do it again. But let's see. So we reached this at the 10th cycle, so we can now skip fast forward to this cycle, and then we have output of 64, which is correct. So this seems promising. So let's try this same thing on the big input. And let's see. All right, 10,000. And that is correct. All right. Right, I'm pretty happy that it worked. I didn't expect it to run this fast, and then actually it seems that it starts to cycle very soon. So that's very cool. That's very nice. So this hash map really helped. So hashing the contents of the map using a hash, and then checking if we already seen that configuration, then finally doing that, skipping those cycles that are not necessary is enough to solve this problem. So yeah, that was a nice one. So we have day 14 solved, and I will see you in the next video, which will be ChatGPT versus this problem, and then we will continue with the other days. So thank you and see you later.